Video, we'll be reviewing the long short-term memory model. The recurrent neural network is a great tool for modeling sequential data, but there are a few issues that need to be addressed in order to use the model on a large scale. For example, recurrent nets are needed to keep track of states, which is computationally expensive. Also, there are issues with training, like the vanishing gradient and the exploding gradient. As a result, the RNN, or to be precise, the vanilla RNN, cannot learn long sequences very well. A popular method to solve these problems is a specific type of RNN, which is called the long short-term memory, or LSTM for short. LSTM maintains a strong gradient over many time steps. This means you can train an LSTM with relatively long sequences. An LSTM unit in recurrent neural networks is composed of 4 main elements: the memory cell and 3 logistic gates. The memory cell is responsible for holding data. The write, read, and forget gates define the flow of data inside the LSTM. Responsible for holding data. Define the flow. The write gate is responsible for writing data into the memory cell. The read gate reads data from the memory cell and sends that data back to the recurrent network. And the forget gate maintains or deletes data from the information cell, or in other words, determines how much old information to forget. In fact, these gates are the operations in the LSTM that execute some function on a linear combination of the inputs to the network's previous hidden state, and previous output. I don't want you to dive into the details of how these gates interact with each other, but what is important here is that by manipulating these gates, a recurrent network is able to remember what it needs in a sequence and simply forget what is no longer useful. Now, let's look at the data flow in LSTM recurrent networks. So, let's see how data is passed through the network. In the first time step, the first element of the sequence is passed to the network. The LSTM unit uses the random initialized hidden state and output to produce the new hidden state and also the first step output. The LSTM then sends its output and hidden state to the net in the next time step, and the process continues for the next time steps. So, as you can see, the LSTM unit keeps 2 pieces of information as it propagates through time. First, a hidden state, which is in fact the memory the LSTM accumulates using its gates through time, and second, the previous time step output. The original LSTM model has only one single hidden LSTM layer. But, as you know, in cases of simple feed-forward neural networks, we usually stack layers to create hierarchical feature representation of the input data. So, does this also apply to LSTMs? What if we want to have an RNN with stacked LSTM, for example, a 2-layer LSTM? In this case, the output of the first layer will feed as the input to the second layer. Then, the second LSTM blends it with its own internal state to produce an output. Stacking an LSTM allows for greater model complexity. So, the second LSTM can create a more complex feature representation of the current input. That is, stacking LSTM hidden layers makes the model deeper, and most probably leads to more accurate results. Now, let's see what happens during the training process. The network learns to determine how much old information to forget through the forget gate. So the weights, denoted as WF, and biases, denoted as BF, will be learned through the training procedure. We also determine how much new information, called X, to incorporate through the input gate and its weights. We also calculate the new cell state based on the current and the previous internal state, so the network has to learn its corresponding weights and biases. Finally, we determine how much of our cell state we want to output an output gate. Basically, the network is learning the weights and biases used in each gate for each layer. By now, you should have a good understanding of the main ideas behind the LSTM. Thanks for watching.